Hello. Let's start with the section 12.5, the arc length and the curvatures. And here's the first example. The first one is sketch the plane curve. We need to sketch the curve. So the first thing, if you need to sketch the curve, this is the first question. So R of T equal to T with the I minus T with the J. T with the J. The point is 0, 2. We need to sketch this one. So the first thing I'm gonna write down the position vector and the vector value function in component form. So 2t and negative t. Then next step, I'm gonna create a small table to check how the graph look like, and pick any 3 points goes between 0 and 2. So I'm gonna say 0, 1, 2. That's gonna be enough. This is for the t, and we need to find the position at these 3 vectors. So here is R over T. So I'm gonna start plugging this one here. So the first point is going to be 2, 0, and 0. The second point is going to be plugging the 1. So it's going to be 2 and negative 1. And the third point is going to be 4 and negative 2. Now, if you want to graph this one, just a simple graph, 1, 2, 3, 4, 5. So the first point is 0, 0. The second point, 2, negative 1. So 1, 2, negative 1 here. And 4, negative 2. 4, negative 2. That's mean we have this line. It's not accurate. And until here, because we need to find between these two intervals, between 0 and negative and 4. So here's our line. Let's check that. If we look here, this one is up, this one is a straight line, this one is goes down, but at this point, at 1, there's something wrong here, I think. No, this is right. So at point 1, we have to graph this one, 2, negative 1. So 2 and negative 1 is not on the line. It's not on this curve. It's curve, but on this one is not a curve because it's a linear. So it's going to be a straight line. So if you look here, 2 and negative 1, it's exactly here. That's why this is the right choice. Now let's find the length. This is a linear. If you look at this one, this is a linear. So we have 2 ways to find the distance, which is the length from this point to this one. So this point is 4 and negative 2. And this one is 0, 0. This one is supposed to be written as a vector. Okay, we can use the distance formula since it's a straight line, which is linear. So let's write down since R of T is linear, that means we can use distance formula which is equal the length. So I'm going to use the distance formula between 2 points. Let's say between this one and this one, which is 0, 0, and 4, 2. I'm going to deal with this now as a point to find just the length. So I'm going to say the distance, this is only the first one. The distance is going to be x2 minus x1 and y2 minus y1 plus y2 minus y1 squared. Don't forget the square, which is equal. It's going to be 4 minus 0 squared plus -2 minus 0 squared, which is equal 16 plus 4. That's mean equal square root of 20. And this is equal 5 square root of 2. This is only because we have a line, so we can use the distance formula. If it's a curve, because we're working with curve now, so here is the second way, which is the integral. That means the distance S is going to be the integral between 0 and 2 to the length of r prime of t with respect to the dt. So that means it's going to be the integral from 0 to 2, the length of r prime. This is r, so that's mean to the 2 and -1 dt, which is mean equal. Let's find the length first. 0 to 2 square root of 2 squared plus -1 squared with respect to the t. That means this one is going to be the integral from 0 to 2 square root of 4 plus 1 dt, and this one is an integral from 0 to 2 square root of 5 dt, which is equal square root of 5t and from 0 to 2. That means this one is going to be equal 5, 2 minus 0, and equal 5. Why I put the 5 under the root? Oh, here, I did something wrong here. Because it's 2 square root of 5. So here is going to be 5 times 2 and equal 2 square root of 5. So here is the distance, which is exactly like the same distance we got from the first one. And with this example, because it's a linear, that's why we can use the distance rule. So here, the length is going to be 2 square root of 5. Let's submit the answer. That's it for this example. With the second one, with the example 2, now this is a curve because you see we have a quadratic here. So it's going to be a curve. So let's work on this example. T cubed plus t squared on the point 0. So this one, you can do exactly the same thing. I'm not going to solve this one for you because you're going to get exactly the same thing. So t cubed and t squared, you're going to do exactly the same thing here. You're going to choose 2 points between 0 and 1. That means you can choose 0 and 0.5 and 1. Plug in this point here to get the y, and you're going to get these points for the vector and just to graph it. Then to find the distance, you can't use the distance formula. For example 2, you can't use the distance formula to find the length, but you have to use only the integral from 0 to 1 and r prime, the length of r prime dt. And do the length is going to be And 100% is going to be a curve. It's going to be a curve. So it's going to be this one. You can't choose this one because this is a line. It's a curve up like this, or like this, or curve is going to be down. So I'm not going to solve this one because you're going to get exactly the same number, t cubed and t squared. Let's go to the number 3. The main thing, I'm not solving these examples because I need you to practice. You see, it's exactly the same thing. So if I solve it, it's going to be easier for you. You're just going to plug in, and that's it. If we go to, this is the third one, 2 sine t, 8t, and 2 cosine. This is a plane, a space, sorry, this is space. Sketch the space curve. So let's check how we're going to solve this one. So the third one, we have r of t equal 2 sine t, 2 sine t and 8t, and 2 cosine t. And the point is from the interval 0 to pi. So let's work on this one and try how to graph it. You can use exactly the same thing. So the first thing it's already in the component form. So what I'm going to do, I'm just gonna create table. Here's t. I'm gonna choose the point 0, between 0 and pi. And let's choose pi over 4. Pi over 2, 3 pi over 4, and pi. And here is pi. Now we're gonna find r of t so we can graph it. So the first thing we're gonna graph, it's a space. We have 3 here. So it's going to be, you're gonna plug in each one, and be careful when you plug in. Cosine t. Okay. So let's use the calculator. First of all, I'm gonna plug in the 0. So 2 sine 0 is going to be 0. So the first one is a point 0. The second one is 0. And the third one is going to be 1. 1 times 2 is going to be 2. Now, let's plug in pi over 4. That means 2 sine pi divided by 4. It's going to be 1.4. So this is 1.4. The second one, 8 times pi divided by 4. So it's going to be 6.2, 6.2428, so 6.3. And the third one is going to, I'm plugging, but I'm going to show you how to know, because the graph with the space, that's mean with the x, y, and z. So let's plug in with the cosine t, that's mean 2 cosine pi over 4. So pi divided by 4, and I close it. So it's going to be 1.4. So also 1.4. 1.4. Then I'm going to plug in pi over 2. 2 sine pi over 2. Pi divided by 2 is going to be 2. So here we have 2. Now 8t, that's mean 8 times pi divided by 4. 6.28. So here, is that the same thing? Pi over 2. I did pi over 4. Yes. 8 times pi divided by 2. 12.56. So I'm going to say 12.6. And I'm gonna plug in pi here. 2 cosine pi over 2. Pi divided by 2 is going to be 0. Now 3 pi over 4. Let's plug in here. 2 sine 3 pi divided by 4 is going to be 1.4. And 8 times t, 8 times 3 pi divided by 4. It's going to be 18.8. Plug in with the third one, 2 cosine t, and it's been 2 cosine 3 pi divided by 4. It's going to be negative 1.4 and 4.1. Okay. The last one, 2 sine t. This one is going to be 0. With the second one, 8 times pi, 8 times pi, which is 25. This is already a big number. 25.1, so it's 25. And the cosine is going to be 2 times -1 is going to be -2. So now I can use these points to graph it. But let's check which one is going to be the graph. I'm going to start from this point. In fact, you have to use all the points to graph it. But let's look to the first point, 0, 0, and the z coordinate is 2. So let's check these. I think I can control. Okay. So let's check the points. 0, 0, and the z is 2. So this one, first of all, 0, 0, 2, the z is positive. So let's check. This is x, and this is the y, and here is the z. And this one, z, x, y, z. Check the z. The point is started from -2. We have +2, so we can't choose this one. Because you see the point is started from -2, the z, which is the first point. That means this is wrong. Let's check this one. This one start 0x, 0y, and the z is 1. We have to start from z2, so this is also wrong. But check the graph, how it looks like. It's a curve and moving like this, keep going around the y. Let's check this one. The first point is 0z and 0y, and x is 2. No, this is wrong. The start point is x, 0, and z is 2. So this is the right one. X is 0, y 0, and z is 2. And you see, keep moving. And if you keep going to the graph, it's going to go around the y and keep moving like this, like a spring on the y coordinate. And check the point here. Z became negative. That's why it's going down. The negative coordinate is going down to the negative z. And then -2, but we stopped here until this point because we need only the interval from 0 to pi. So that's how we're gonna see which one is the right graph. Now to find the distance, now we can't use the distance formula, so we're going to use the integral. Before I start doing the integral, I'm gonna find r prime, which is equal -2 sine cosine. -2 cosine t the derivative is going to be 2 cosine t and 8, and the derivative of 2 cosine is going to be -2 sine t. Then next step, so it's going to be easier for me. I'm going to find the distance, which is the integral from 2 to pi, the length of r prime, which is, let's write down the rule first. dt. That means the distance is going to be the integral from 0 to pi so the integral from from 0 to pi is going to be for this function, so it's going to be for 2 cosine t, and for the 8, in fact, it's the length, not just the integral. The length for this one, so I'm going to take the length first, and for 8, and for -2 sine t dt. So this one is going to be equal the integral from 0 to pi, the square root of 2 cosine t squared plus 8 squared plus -2 sine t squared with respect to the t. So dt. And this one is going to be the integral from 0 to pi. It's going to be the square root of, let's do this one is going to be 4 cosine squared to the t plus 64 plus 4 sine squared to the t dt. And I'm going to take the 4 with the cosine on the side. And so it's going to be the integral from 0 to pi, the square root of I'm going to take the 4 as a common between these two terms. So cosine squared to the t plus sine square root to the t plus 64 dt. So it's going to be the integral from 0 to pi 4 times 1 plus 64 dt. And this one is going to be equal the integral from 0 to pi 64 is going to be square root of 68. Now we have to with respect to the t. Now it's easier to find, we just simplify it. So this one is going to be, this is equal square root of 4 times 17 t from 0 to pi just have to find the root, which is 4 times 17. That means it's going to be 2 square root of 17 and pi minus 0. And the result is going to be 2 square root of 17 pi. So this is the final result. Here we go. This is right, 2 square root of 17 pi. Let's move to the next one. Now find the curvatures k of the curve where s is the arc length parameter. So this is question 4. We have rules. It says to find the curvatures The rules it says to find the curvatures, we have to find the curvatures k. Example 4. Find the curvatures k of the curve. Okay. So what I'm going to do, here is the rule. It says for example 4. That means the curvatures k equal the length of r prime with respect to the t over, sorry, not the r prime, the t. So we have to find the t. T prime with respect to the t over the length of r prime. So here's the curvatures for the curve, where s is the arc parameter. So we have now the parameter, the s. So r of the s, the function we have 2 plus s I plus j. 2 plus s for the I plus j. Careful, this is all for I. That means r to the s is going to be 2 plus s and 1. So now this is, I wrote down this one with respect to the t, but now we have r with respect to the s. So we're going to use, to find the curvatures, we're going to use for s as a vector. Okay. So now the first step, I'm going to find the prime. So r prime for the s is going to be 1, because this is 0 and 0. 1 and 0. Do we need the double prime? The length, we don't need the double prime. The length for r prime for s is going to be the square root of 1 squared plus 0 squared, and it's going to be 1. The length is going to be 1. Then we need to find the t. T for the s is going to be r prime to the s divided by the length of r prime to the s. This is from the previous section, which is equal, is going to be r prime, which is 1, 0, and everything divided by 1. So it's going to be 1, 0. Then this is the t for s. T prime for s is going to be 0, 0. Then the curvatures is going to be the length of t prime with s divided by the length of r prime to the s, which is equal, this is 0 divided by the prime, here's r prime over s, the length is 1, which is going to be 0, 0. It's a length, so the curvature is going to be, because it's a length, the length for this one, I then find the length for this one, which is going to be 0. That's going to be square root of 0 plus 0. Just to know that, so it's going to be square root of 0 over 1. It's going to be 1. Sorry, going to be 0. So that's mean the curvatures here, just we're going to put 0, and that's it. We're going to do exactly the same steps with the next example, but now we have 8 cosine 4 ti plus 8 sine 4 tj. So let's find the curvatures k of the curve when we have 8 cosine 4 pi t and 8 sine 4 pi t. So we're going to do exactly the same steps. We have the rule to find the curvatures. So the first thing I need to find the r prime of t, which is going to be. So be careful here. So when we find the derivative, so 8 sine, which is negative sine, so it's going to be negative 8 sine 4 pi, and if for the derivative, the chain rule for the derivative inside, so it's going to be 4. So times 4 pi. So times 4 pi. And here it's going to be the same thing, 8 sine, the derivative of the sine is cosine 4 pi, and the derivative for the angle is going to be 4 pi. 4 pi t, I forgot the t. So we have to find the derivative with respect to the t, and the derivative here with respect to the t. So here is the t, and here is the t. And so it's going to be times 4 pi. That's mean r prime of t is going to be negative 32 pi sine 4 pi t and here 32 pi cosine 4 pi t. Okay, so now here we go. Everything is set up. This is the next step. We're going to find the length with the r prime, which is going to be the square root of, that's why I have to be careful here, this one squared plus this one squared. So it's going to be negative 32 pi sine 4 pi t squared plus 32 pi cosine 4 pi t squared. And this one is going to be equal the square root of, I'm just going to say 32 pi squared and 32 pi squared from this one. So that's mean is going to be only 32 pi squared. Let's write it down. I'm going to take, let's write it down. Sine 4 sine squared 4 pi t plus, and here is 32 pi squared cosine squared 4 pi t. Then this one is going to be this one plus this one. Take these are as a common. So because this one is positive, this one is positive, so we're just gonna take 32, which is a really big number if you just square it. So I'm gonna keep it 32 pi squared as a common, and here's going to be sine squared 4 pi t plus cosine squared 4 pi t. Everything here is equal 1. That means it's going to be the square root of 32 pi squared, 32 squared pi squared, which is equal 32 pi. So this is the length. Now we need to find the tangent with respect to the t, which is going to be r prime of t divided by the length of r prime with the t. So it's going to be r prime. Everything here which is negative 32 pi sine 4 pi t and 32 pi cosine 4 pi t, and everything is divided by 32 pi. The same thing, take these, it's gonna cancel, so with the pi, so it's gonna be just negative sine 4 pi, negative sine 4 pi t, and cosine 4 pi t. That's mean tangent with respect to the t is going to be only negative sine 4 pi t and cosine 4 pi t. Then the creative curvature is going to be the length of the tangent prime over t divided by the length of r prime over t. We didn't find the tangent prime, so we have to find the tangent prime first so we can use this rule. Here we go. Let's find it here. The tangent prime is going to be negative 4 pi cosine 4 pi t, and it's going to be 4 pi, the derivative of cosine sine 4 pi t. It's going to be negative also. So also it's going to be negative 4 pi sine 4 pi t. Now we're just going to plug in this one. K is going to be equal t prime, which is negative 4, the length for this one. The length for negative 4 pi cosine 4 pi t and negative 4 pi sine 4 pi t over the length of r prime, which is here is r prime, the length is 32 t. 32 pi. So now take the length for this one. So it's going to be square root. This is squared, this is squared, this is squared, this is squared. We can square everything here. And then take it out. Let's see. Over 32, cancel everything. So let's keep going. The curvature is going to be the square root of over 32 pi. And this one is going to be the first one squared. That's mean negative 4 pi squared. And this one is going to be cosine squared 4 pi t. And plus this one is going to be also negative 4 pi squared. And this one is going to be sine squared 4 pi t. Sine and the cosine is going to be 1. This one and this one is going to be 16. Pi squared, you're going to take it out. So it's going to be 4 pi over 32 pi. So next step, k is going to be, I'm going to say square root of negative 4 pi squared as a common. And here's the cosine square 4 pi t plus sine squared 4 pi t. And everything is here over 32 pi. This is 1. So square this one, 16 pi squared. Then take the square root for 16 is going to be just 4 pi divided by 32 pi. And then it's going to be 1 over 8. Let's check this one. Here we go. This is right. Just when you do these steps, take your time, do it step by step because it's easy to make mistakes. Next example, 6. Now this is a little bit different. I'll leave this one a little bit here so you can write down. Example 6. Find the curvatures and the radius of the curvatures of the plane curve at the given point x. So the curvatures is k. The radius is going to be 1 over k. There's two formulas. There is in fact 2 formulas for each. You can just find the radius by saying 1 over k. It's easier to find. But the thing here, check our coordinates here. Y equal 5x, 4 over x, and x equal 2. And they ask us to find the curvatures and the radius. That's mean with the curve. So that's a little bit different. Example 6 and 7 on the previous examples. So let's check how we're going to solve this one. The first thing we have to do with example 6, let's change the page. So example 6, it says y equal 5x, y equal 5x minus 4 over x, and they say x equal 2 at this point. So the first thing, I'm going to write down y equal 5x minus 4x to the negative 1, because it's easier to find the derivative. So y prime is going to be 5 minus, it's going to be plus 4x to the negative 2. I'm just finding the derivative for this one. Then from this one, I'm going to say y prime to the 2 is going to be, so when you have xy and you need to find the curvatures and the radius, you're going to use a new formula. I'm going to show you the new formula. If you check the slides, there's a new formula when you have xy coordinate. Find, here's y prime, then y prime at this point, that means going to be 5 plus 4 over 2 squared, which is going to be 5 plus 1 is going to be equal 6. So here is r prime for the point 2. Now let's keep going. Find y double prime equal. I'm going to go back here. This is the y. This is the y prime. Find the derivative for this one. So it's going to be 0 plus. This one is going to be negative 6x negative 3. I don't have to write down the 0. So negative 8x to the negative 3. That means this is equal 8 over x cubed. Then y double prime to the number 2 when x equal 2 is going to be 8 over 2 cubed, and it's going to be 1. That's what I'm going to use. Then it's negative 8, so it's going to be negative 1. Then next step, the formula we're going to use to find the curvatures, if we have xy coordinate, is going to be the absolute value of y double prime of the point, let's say of the point, let's check of the point x over, this is the rule, 1 plus y prime to the x squared, and everything over 3 over 2. So this is the formula you're just going to exactly use in it. That's mean k is going to be equal the absolute value of y double prime over 2 over 1 plus y prime over 2 squared, and everything to the 3 over 2. So this one is going to be the absolute value of negative 1 over 1 plus y prime over 2, y prime over 2, which is 6, 1 plus 6 squared, and everything 3 over 2. 6 squared. So do we have here, there's something wrong here when I find y prime. No, that's right. So let's keep going. So now this is going to be 1 over 1 plus 36 to the 3 over 2. And now we have to simplify it. Let's try to plug in this one for the k, 1 over 37 to the power 3 over 2. That means the radius 1 over k is going to be 1 over k, which is 1 over 37 to the 3 over 2. And that means this is equal 37 to the negative 3 over 2. So just the opposite one. I think this one, this one we can write down as a negative. Write down this one, flip this one. This is the positive, you don't have to. But this one you're gonna write down with the negative. So the curvature is going to be 37 with negative 3 over 2. Let's check these two solutions. That means k is going to be 37 to the exponents negative 3, negative 3 over 2. And let's check the radius. 1 over k is going to be 37, and the exponent is going to be 3 over 2. There we go. That's it. You don't have to simplify it, just keep it like this. Next example, we're going to do exactly the same thing, but be careful. We have this function when x equals 6. So let's check how we're gonna solve example 7. For example 7, we have y equal e to the negative x over 2 over 3. And x equal 6. So we're gonna do exactly the same steps. So first of all, y prime to the x is going to be, I don't have to write down the x, we need a space. So y prime is going to be, I'm going to find the derivative for this one. So the function with the derivative of the exponents. So it's going to be, here is the function times the derivative of the exponents is going to be 1 over 3. That's mean y prime is going to be negative 1, 3, e to the negative x over 3. Let's find with the point y prime to the point 6 is going to be negative 1/3 e negative 6 over 3. And this one is going to be negative 1/3 e to the negative 2. So here is the y prime to this point. Now let's go to y double prime. It's going to be, here is y prime. We're going to find again the derivative for this one. So it's going to be negative 1 over 3 e to the negative x over 3 times, again, negative 1/3. That's mean it's going to be equal y double prime equal 1 over 9 e negative x over 3. Then y double prime over 6 is going to be 1 over 9 e negative 6 over 3, which is equal 1 over 9 e negative 2. Here we go. So next step, we're just going to find the k, which is k equal the absolute value of y double prime to the 6 over 1 plus y prime to the 6 squared to the 3 over 2. So it's going to be y double prime to the 6 negative 1/3 absolute value of negative 2 over 1 plus y prime is negative 1/3 e to negative 2 squared and everything to the 3 over 2. Then next step, we're done from this one. Here, this is the, the absolute value for the number. I'm just gonna write down this on the bottom. That's mean k is going to be equal 1 over 3 e squared over, this is 1 plus 1 over 3 is going to be 1 over 9 e to the negative 4 and everything 3 over 2. Let's try to simplify it more. What I'm going to do on the top, I can't do anything, but here I'm going to take as a common, which is 1 over 9 e, just factor it out. And this one is supposed to be positive because we square it. No, So this one is positive. So 1 over 3 e squared over, I'm going to say e 1 over 9 e to the power 4 out. So here is going to be 9 to the power 4 plus 1. If you distribute now this one with this one, I have to do it 1 over 9 e to the power 4. So when you distribute this one now, you're going to go back here. So now this is easier. In fact, this is going to be the exponents for everything. Because now I can write down this, take the reciprocal for the second one. This one is easier to take the exponents for it. So it's going to be equal 1 over 3 1 over 3 e squared over 1 over 9 e4, and this one the other side, which is 9 e4 plus 1 to the 3 over 2. So now this one is going to be 1 over 3e squared over, if you look to this one, if you take the root, this is a root for it, is going to be 1 over 3 e squared. I'm taking the square root because this is the root, this is exponents. So it's going to be 1 over 3 e squared. And now we have to cube it. And leave the other side. We can't do anything here because we have two numbers. Yes, that's right. Let's check what we're going to do next. I'm going to cube. So on the top, 1 over 3 e squared stay the same. And on the bottom is going to be 1 over 27 e to the power 2, 2, 2. So it's going to be e to the power. We have something wrong. E to the power 6. I think it's okay. Let's keep going. 9 e to the power 4 plus 1 and the 3 over 2. Then this one is going to be, now what I'm going to do, I'm going to write down this one, flip the division to multiplication. So flip this part. So it's going to be 1 over 3 e squared times 27 e to the power 6 over 9 e to the power 4 plus 1, 3 over 2. 27 with the 3, so it's going to be 9. And this one as exponents minus this one, so it's going to be 4. That's mean here is going to be, this is only for the k. It's going to be 9 e to the power 4 divided by 9 e to the power 4 plus 1 to the 3 over 2. Let's write down this. So for the k, you're just gonna flip it because 1 over k. That's mean this one's going to be equal. This is the k. We said 9 e to the power 4 divided by 9 e to the power 4 plus 1 to the 3 over 2. 1 over k is going to be, you're just gonna flip this one. So it's going to be 9 e to the power 4 plus 1 to the 3 over 2 divided by 9 e to the power 4. Let's check. We did everything step by step. Let's see. K is going to be 9e to the power 4, 9, what I'm going to find the exponential, e to the power 4, and over parentheses 9e to the power 4, 9e to the power 4 plus 1, and everything here to the exponent 3 over 2. And the second one, we're just going to flip this one. So it's going to be another, it's going to be the parentheses here, 9e to the power 4, 9e to the power 4 plus 1, and here with the exponents 3 over 2, and on the bottom part here is going to be 9e to the power 4. Let's check. Let's check. Did I type 3? Select another 3. Here's the wrong thing I did. I was looking where is the wrong thing. When I plug in y double prime is not 1 over 3. It's 1 over 9. So this one is 1 over 9. And keep going. So this one is going to be 1 over 9 here. And here is going to be 1 over 9. And what I did here, it's a negative, then I have to bring it down. So that's here, -4. And then you're going to write it down. So this part is going to be 1 plus 1 over 9 e to the power 4. Just to make it simple for you, then you're going to take 1 over e to the power 4 out. Here's going to be 9 e to the power 4 plus 1. So from this step, you're going to go here. Then this one is going to be 9. This one is going to be 9. It's just a little bit mistakes. Everything is going to be wrong. Then this one is 9. And here it's going to change. Because when you cancel the 9 with the 27, it's going to be 3. That's why I change it and post it to check the solution. So now this one is going to be 3 to the power 4. So let's change the second one also to just 3 and submit. So that's it for this example. It's only small mistakes, everything is going to be wrong. Let's go to example 8. Example 8, it says y equal 3 cosine x over 3 over 2 over 3 over 2. And x is between pi and 0. That's mean on the interval 0 pi. Let's check how we're going to solve this example. The first thing we're going to find y prime is going to be -3 sine x over 2 times the derivative of inside, which is half. That means y prime is going to be -3 over 2 sine x over 2. Y double prime is going to be -3 over 2 cosine x over 2 and times another half. That means y double prime is going to be negative 3 over 4 cosine x over 2. So that's what we're going to use. And y prime, well, I'm going to use. That's mean k is going to be, but check, this is the first thing. Find all points on the graph of the function such that the curvatures equals 0. That's mean when you find the k, we need to find all points. When you need to find k, k is going to be equal 0, then you're going to solve it. So I just found the y, because that's what we're going to depend on to find the curvatures. So it's going to be the absolute value of, the rule is absolute value of y double prime to the point, which is, we can't choose any points here because we don't have points, so we have to write down in general of over 1 or plus y prime to the x squared to the 3 over 2. Then we're going to plug in this one here. It's going to be the absolute value of y prime, which is negative 3 over 2 sine x over 2 over 1 plus y double prime, which is negative. So here's, I always do this mistakes. This is the y double prime. So cosine, this is the cosine, and here's the y prime, which is negative 3 over 2 sine x over 2, and this is squared, and everything is 3 over 2. So be careful here. Let's put this one as a bracket. Okay, and this is squared. Then we just need to simplify this one, or you don't have to simplify it from now because we found the curvatures. We just need to find the point. When the curvatures equal 0, that means k equals 0. Capital K equals 0, which is this part is going to be equal 0. So that's mean negative 3 over 4 cosine x over 2, the absolute value, over 1 plus negative 3 over 2 sine x over 2 squared 3 over 2 equals 0. So this one equals 0 if and only if the denominator equal to the 0. So it's going to be absolute value of 3 over 4 cosine x over 2 equals 0. The absolute value equals 0 if and only if everything inside equals 0. That's mean from here, divide both sides by negative 3 over 4. So cosine x over 2 is going to be equal 0. Cosine x equal 2 equals 0 if and only if the angle equal to the 0. That's mean x is going to be the angle equal to the 0, but we need to find how much is going to be the angle. That's mean in this case x over 2 is going to be equal pi over 2 plus k. K is not the same k here, pi. Let's do it not k. Let's do it p. Don't want to confuse you, but always they're using k. equals 0. So now we're going to solve this one. Divide or times by 2, because we need to find the point x. So it's going to be x equal pi plus 2k pi. K is not the same k, the curvatures. Now, if k equals 0, that means x is going to be equal pi. Pi is include the interval. If k equal -1, x is going to be equal pi minus 2 pi, which is equal -pi. This is not belong to the interval. So I'm going to say no. This is yes. If k equal 1, so x is going to be equal, because only on the first quarter, x is going to be equal pi plus 2 pi, which is equal 3 pi. And this is not belong, so I'm going to say no. So that's the only when x equal 0. So we're going to write down as a point when x equals 0. Then how much is going to be the y? The y you're going to plug in when x equal pi. That means x equal pi, so y is going to be, we're going to find the y, because we need to write down the point. So x is pi, y is going to be 3 cosine pi over 2, which is equal 3 cosine pi over 2. Pi divided by 2. So it's going to be 0. That's mean x is pi, y is 0. Let's try this one. Yes. So x is pi. Oh, I'm gonna find the pi. I think yes, here is the pi, comma y is 0. Here we go. That's it. So for the last two, they're just telling you if you check the slides, the arc length, you can use this formula to find on the interval. We use the formula, this one, and for the second one, they're telling you the curvatures, which is that's what we used if we have the curve. So this one is a true, and this one is also a true. So that's it for this section. Let's try submit this one and the other one. Watch the slides for this formula. You see, that's what I told you. For the curvatures, there is two formula. There is this one and there is this one. I always using this one, which is up to you. If you want to use the length for R prime cross the product with the R double prime over I prime cubed, the length of R prime cubed, you're gonna get the same result. So it's up to you which formula you're going to use. That's it for this section.